Colour is fundamental to expressing who we are and our place in the world. Originally, pigments and dyes came from the earth and nature. Through time, the creation of new colours has gone hand in hand with cultural and technological change. Today, we have more colours than we can possibly perceive. We have always sought new colours because we need them. They tell our story. Many fields of study are united in our quest to define and understand colour. Science, the arts, history, psychology, anthropology. Each discipline offers a piece of the puzzle, a chance to crack the colour code.
This is where the old people, the ancestors, they used to come.
The ancestors?
Yeah, the whole tribe, they used to come and live.
And obviously there were lots of artists here. There are paintings everywhere.
Yeah, there are.
Ali alu, alwajan ngat bere. Pen kang urut, pen kurmek, kun wok bubi ga pen wong. Pen wong bed bere, kun mau gur, kun gula. Pen kurmek wol bubi ga, taparapol pen kanaka, ala alepi.
The creation spirit for many of Australia's indigenous people is known as the rainbow serpent. It can take animal and human form.
The rainbow serpent is the most colourful being of all and is associated with creativity and in a sense is Mother Nature.
For the Gonwingu people, a rainbow in the sky represents the soul of the rainbow serpent, travelling from one waterhole to another. Colour embodies their spirituality.
In Gonwingu country and across Arnhem Land, there are lots of stories involving colour. Often people say that spirit children living in water holes look like little tiny pieces of colour or tiny brightly coloured fish. People try to tap into ancestral power in order to bring meaning into their lives and to perpetuate their traditions by doing paintings and by telling the stories associated with all of these things. So colour is the thing that links everything together.
The most ancient of pigments known to man are ochres from the earth and charcoal from fires.
The red ochre endures longer than any other pigment, and that's because it's very fine-grained and it penetrates the porous sandstone and it forms a very tight bond, and therefore it lasts through thousands of wet seasons. Other colors like white, they're very thick, they're very coarse, they just sit on the surface and then they quickly peel off.
To make paint from ochre, they need to mix it with a binding agent.
In old days, they used to use milkwood tree, themselves, sticky one. But in rock art, it's different. They used to use with coconut and a little bit of kangaroo blood. Coconut fat and kangaroo blood. Red ochre, mixed up with red ochre.
Today, they bind the ochre with PVA glue.
All of the paintings in the rock shelters have very important stories associated with them. Stories connecting people to land, to other creatures, and to other people. And so the contemporary artists are very concerned about passing on those stories, those traditions, and it's a living culture that continues and is bright and alive today.
While the men paint, the women weave dilly bags. Dilly bags reminiscent of those carried by the creation spirit, Yingana.
Here once when they used to finish the arts, and then they used to come around up here, sitting around, showing their kids, telling stories of these landscapes. This is now where we come and teach our young children, showing the rock arts, the arts that may have stories, the colors, that's are most important for us.
From the beginning, the creation of new pigments has coincided with technological innovation. The first people to introduce chemical technology to color making were the Egyptians.
C'est vrai que des légendes racontent que des voyageurs transportant justement du natron, des réserves de cuivre, ont voulu faire un feu et ont mis ces différents matériaux autour du foyer. Et au réveil le lendemain, sur le sable donc, qui constituait le désert, ils ont eu la surprise de découvrir ce matériau bleu.
This vase is carved from one piece of blue material that resembles sandstone.
On l'avance.
In the Louvre Museum in Paris, researchers are trying to discover how it was made.
Là, c'est bon.
Je crois que ça peut aller. On finit
Oui.
la table.
À partir du 7e siècle de notre ère, toutes les recettes de fabrication de ces pigments ont complètement disparu. Donc c'était tout à fait un travail de détective, qu'à le dire, pour essayer de remonter à ce mode de fabrication qu'étaient ces pigments.
A high-powered particle accelerator may offer some clues. A stream of protons excite atoms, which give off X-rays that allow the researchers to identify the constituents of the pigment, and even the heat of the furnace that made them meld.
C'est-à-dire qu'il y a à la fois des restes siliceux, dans des souvenirs du quartz qui rentraient dans la composition de ce pigment initialement, et également des phases mêlant cuivre, calcium, silicium en différentes proportions.
The vase is solid Egyptian blue, one of the first synthetic pigments ever produced. It was widely used in jewelry, painted on papyrus, and decorated the interiors of tombs. The mysterious objects we so treasure were designed to accompany the pharaoh into the afterlife. Egyptian technology produced colors to last for eternity.
Making colours has always been linked to other technologies, to making the sort of stuff that we need for our daily lives. So making soap or glazes or metals or now plastics and synthetics. All of these industries have, as an offshoot, tended to produce coloured substances that artists have sort of seen and recognised and made use of.
احنا بعدنا بالارض هون تبع ال8 امتار. يعني الارض تقريبا منيحه صارت هيدي كلها.
Off the coast of Lebanon lives a creature that colored the robes of an emperor. In ancient times, color denoted status. Murex shellfish, the source of the Roman Empire's most precious colour.
من 5000 سنة أيام الفينيقية كانوا الفينيقية يجيبوا البواق ويكسروا ويصبغوا الصوف ويغزلوه ويطلعوا بالمراكب تبعهم ويروحوا على بلاد أوروبا على واحد
بزيادة هالقد؟
ايه بالزيادة بس هلا صرنا بدنا نحط رماد.
لشو الرماد؟
رماد مشان يزكي اللون.
يعني بيعطي لون أحسن هذا
ايه بحط رماد
بلش يطلع اللون يعني.
ايه هلا حطينا البواق وبدنا ننقعهم 9 أيام.
The interesting thing is, when you extract it from the shellfish, it's not coloured at all. It's just a sort of fairly whitish, translucent liquid, and it has to go through a certain chemical process before it becomes this bright purple dye. So the Phoenicians figured out how to do this.
A little like an ancient photographic process, exposure to sunlight brings about a magical transformation. Mucus from a gland in the snail contains an indigo dye stuff that turns blue in the air. Red-brown bromine extracted by the snail from the sea binds to the indigo to produce a non-fading purple dye, the colour of which grows deeper as it dries.
It was a hugely labour-intensive and expensive process. It required something like 250,000 shellfish to make a single ounce of dye. And it was produced in the imperial dye works in Rome, eventually for pretty much the exclusive use of the emperor. Certainly anyone trying to make this imperial purple outside of the official dye works was liable to be killed for it.
Les premiers musulmans, en fait, viennent de la péninsule arabique, qui est un milieu extrêmement aride, où il y avait déjà un amour du vert bien avant l'islam, dans la mesure où le vert, c'était l'oasis et qui allait permettre de se désaltérer, de se reposer, de manger. En fait, c'était vraiment lié à la vie.
The Persian word for green is the same for garden and paradise. In Medina, the Prophet Muhammad united his tribes behind a green banner, and today many Islamic countries have green in their flags.
Cette prégnance de la couleur verte dans les cultures arabo-islamiques va amener forcément les artisans aussi à développer un certain nombre de techniques pour que ce vert soit présent dans l'environnement. Les tuiles vernissées, enfin tous les supports des arts du feu avec des couleurs vertes. Et c'est assez compliqué parce que les émaux qu'on utilise, enfin les colorants qu'on utilise pour faire ces couleurs dans les arts du feu n'ont jamais la couleur qu'ils vont avoir après la cuisson.
The Moroccan city of Fez is famous for the green tiles they've been making here for over 1,000 years.
J'ai hérité de ce métier de père en fils depuis des siècles et des siècles. La couleur verte se compose de plusieurs minerais que nous fabriquons nous-mêmes avec de la silice, du plomb. La première étape, c'est que nous faisons fondre le plomb dans des fours spéciaux, des fours chimiques. Et on les malaxant au bout de 3 à 4 heures et nous obtenons une poudre. Nous ajoutons de la silice écrasée et lavée et très fin. Et on ajoute encore 7% de cuivre. Et nous obtenons la couleur verte. Voilà.
The process of making the green tiles has changed little since the 9th century, a time when working with metals took on a magical quality. The Islamic world used emerging ideas, particularly chemistry, to take color making to a new level of sophistication.
The Islamic culture of the time was a far more advanced culture than existed in Europe. And so, to an extent, Europeans relied on the Arabs for a lot of their learning and technology. A lot of scholars in Europe learned Arabic in order to be able to understand the science and technology.
Europeans used techniques derived from Islamic culture to produce a color that became the most valued in all of Christendom: vermilion.
Vermilion is mercury sulfide. One starts with mercury and either melts sulfur or grinds the sulfur in with the mercury.
The poisonous elements are combined to produce a very pure, almost sacred red. In the process, alchemists saw a spiritual meaning beyond the physical.
In alchemy, the mercury stood for the spirit and sulfur stood for the material world, and the union of these two would produce gold, they believed.
There's undoubtedly a spiritual connotation to alchemy. It's about purifying substances, but there's also a very practical, very pragmatic strand to it. When they spoke about alchemy, what they really meant was just what we mean today by chemical technology. It was a way of making stuff.
In medieval times, most art was religious. It was the church that commissioned major works. Few could read, so frescoes, stained glass, altarpieces and icons were used to convey the story of Christ to the people. Color making was controlled by a closed fraternity, the guilds. The guilds protected standards. Expensive materials had to be allowed to speak for themselves. A color's purity was not to be adulterated.
Gold is obviously an expensive medium. Most people couldn't have it in their house, but it was in their church. But it wasn't just used because it was expensive. It's used in religious images primarily because it reflects light. So it was chosen for its theological value, perhaps more than its expense.
To get the pigment to adhere, egg is used as a binding agent. For something so delicate, it's incredibly durable.
Particularly after the 9th century, most icons were painted in egg temperature. It dries quite quickly, so it lends itself to quite an aesthetic, luminous result. One paints icon starting with dark and moving through to light. So because white reflects fullness of light, that is light and often stands for God. So when I paint icons, I'm praying with colour, I'm praying with paint.
Aidan has left the vermilion till last. The alchemist's brew is ready.
The more one grinds it, the redder it gets. Cimini says something like, if you grind it every day for 100 years, it's all the better.
In early Christian art, vermilion became the most precious of colors, reserved for the most sacred of subjects.
An icon depicts not mere human persons, not mere matter, not mere creation, but human persons, matter, shot through with the glory of God. It's matter transformed, transfigured, enlightened by God's light, by God's presence.
But the glory of vermilion was to be overtaken by an extraordinary colour from a distant land, a colour that would transform the religious and cultural life of Europe.
Marco Polo va aller justement vers l'Orient. Il va découvrir en Afghanistan des mines de lapis-lazuli et ça va être le premier qui, en revenant, va dire c'est la couleur la plus pure et la plus belle que je n'ai jamais vue.
From before the time of the pharaohs, the world's best and most expensive lapis lazuli came from this mine in northern Afghanistan. This striking blue pigment is still mined here today. It was the Italians who gave the brilliant blue a magical name, ultramarine, meaning from beyond the seas. Dr. Muriel Vervat and her team from the Uffizi Gallery in Florence are working on a 14th century altarpiece. In the past 600 years, it's undergone a number of restorations.
E questo si può utilizzare per riuscire a riconoscere pigmenti che all'occhio, cioè nel visibile, appaiono più o meno nello stesso, esatto, uguali, ma che sono in realtà nell'infrarosso
diverse. Esatto.
The team suspect that restorers in the 18th century used an inferior cobalt blue. They resort to infrared scans to find out.
Magari se ci sono dei pigmenti che non sono ovviamente trecenteschi o che sono comunque successivi, se troviamo, non so, dei ritocchi al cobalto, praticamente siamo sicurissimi che quel pigmento non è originale. Eccolo qua.
Si può vedere la componente infrarossa. E una cosa che si può vedere è che mentre il blu, cioè l'azzurro delle ali dell'angelo diventano rosse, che potrebbe essere indice della presenza di lapislazzuli, il manto della Madonna rimane molto scuro. E questo potrebbe essere dato da ridipinture successive, quindi con materiali diversi.
Muriel Vervat is on her way to visit a man who nurtures the old ways of colour making. Massimo Zecchi's family have been making colour in Florence for over 300 years.
J'aurais besoin d'un beau bleu bien intense parce que c'est une vierge qui a un manteau qui est très sombre et avec des chutes de couleurs qui sont importantes, et donc j'aurais bien aimé avoir quelque chose
on a la meilleure qualité
beau.
Maintenant.
Oui, oui.
Nous avons un très beau pierre de lapis-lazuli de l'Afghanistan.
To turn the semi-precious lapis stone into brilliant ultramarine, it's ground up. The purer the lazurite, the more intense the pigment. In the late Middle Ages, Florentine painter Cennino Cennini described the process.
Get some good lapis, the richest in the blue color. That which contains the least ash color is the best. Pound it in a bronze mortar. Take a coveted sieve such as the druggists use for sifting drugs, and sift it. And pound it again as you find necessary. And bear in mind, the more finely you work it, the finer the blue will come out. 6 ounces of gum mastic, 3 ounces of new wax for each pound of lapis. Put all these things into a new pipkin and melt them together.
C'est bon pour vous, c'est pour votre travail.
Ah oui, ce sera parfait. Mais le bleu lapis-lazuli était quelque chose d'absolument extraordinaire, même pour nous qui travaillons dessus. C'est quelque chose qui éblouit. Quand on commence à retoucher et qu'on utilise une couleur qui est la même que la couleur originelle, et donc on obtient exactement la même luminosité, la même intensité, d'un seul coup, c'est comme si tout devenait compact de nouveau. C'est comme si on voyait apparaître certains petits détails qui étaient tout simplement en sommeil, quoi. Et ça, c'est des moments vraiment extraordinaires.
By the Renaissance of the 15th century, the church wasn't the only patron of the arts. Merchants made rich by trade started commissioning their own works. Painting took on a more secular flavour.
At the same time as this class was emerging, the sort of intellectual life of Europe was changing. It was the age of so-called humanism, and it eventually led to a change in the way people visualized the world through art. They began to think about the world in more naturalistic terms. Painters and artists began to depict scenes as we would see them more realistically. That also led to a demand for more colour, because if you want to paint the world naturalistically, then you need the colours that you see out there.
The new colours arrived by the expanding trade routes. Artists started mixing them with oil rather than egg. It was a technological breakthrough with dramatic results.
These oils are much slower to dry and they give a different sort of consistency to the paint. So what this encouraged was the use of techniques for blending colours together. You could create a sort of more subtle mix, and also you could create these warmer tones, these warm flesh tones that we tend to associate with Renaissance art.
The new colours fueled an age of artistic genius. Thoughts of piety may have lurked in the background, but Renaissance artists were liberated to revel in the depiction of natural beauty. By the late 18th century, the colonial powers had carved up the world. Colours from the colonies were in great demand. A significant part of the wealth that flowed to Europe came from dyes. Dyes from flowers, vegetables, wood, and animal products. The challenge has always been to stop dyes fading, to make their colour fast. For over 5,000 years in the Middle East and India, they used mordants like alum and other metal salts, and sometimes even urine to fix the colour. A dye is different from a pigment in that it's absorbed by another material, while a pigment tends to sit on the surface like paint. Red from poppies, yellow from saffron, blue from indigo. Indigo is a weed that grows almost anywhere. But in India, it became an industry that returned fat profits to Britain. The yellow plant extract gradually turns a deep blue when exposed to air. Indigo is probably our oldest dye because it's so simple. It doesn't require a mordant to deliver strong, lasting colour. British indigo coloured the clothes of factory and farm workers around the world, as well as the uniforms of French and Prussian armies. But the British themselves wore red. The soldiers that enforced Britain's hold on empire were known as the Thin Red Line due to the colour of their tunics. The bright red, no doubt, served well to hide any blood that might be spilled. Ironically, the British had to purchase the dye for their uniforms from one of their biggest rivals for colonial power. In the Americas, Spain found a colour that would become as valuable as gold. It was the brightest, strongest red the world had ever seen. What was the source of this perfect red?
Es un bicho que es un parásito que antiguamente llamaban plaga. Según la historia, creo que este lo utilizan en los países más grandes.
Cochineal insects are parasites that suck nutrients from the prickly pear cactus. The females produce a red carminic acid to deter predators.
El carmín es un líquido más espesa. El color cuando propaga ya tiene su tinta. Ya tiene tinta. Y cuanto más maduro, más tinta tiene. Ese es el carmín.
The wealth from the colonies helped fuel the Industrial Revolution taking place in Europe. And in time, that dramatic change would lead to the decline of village-based dye-making in the colonies.
Igual no está tan buena esta cochinilla, le falta madurar un poco.
Ironically, it was another insect that was partly to blame. In the 1850s, malaria had spread from equatorial regions right across Europe. The only known treatment for the deadly disease was quinine, made from the bark of a South American tree.
There were thousands of people dying of malaria all over the world, and there was nowhere near enough quinine to actually help those people. So to produce it synthetically was something that was very desirable.
While looking for ways to synthesize quinine, an 18-year-old student from London's Royal College of Chemistry made a remarkable discovery. His name was William Henry Perkin.
William Henry Perkin started a chain of events which have since changed the world.
I was endeavouring to convert an artificial base into the natural alkaloid quinine. But my experiment, instead of yielding the colourless quinine, gave a reddish powder. With a desire to understand this particular result, a different base of more simple construction was selected: aniline.
Aniline is a derivative of coal tar, which was one of the waste products from the coal gas industry. And he managed one day to produce, in a test tube, a small amount of black tar-like precipitate, a gunge basically, which, when he added some alcohol to it, turned a beautiful purple colour.
Perkin had the wit to realise that the dark gunge could be worth a lot of money. He'd invented a convenient synthetic dye that was quick to produce.
Prior to 1856, all dyes were produced from natural items, and production of the dyes was very long and laborious. Sometimes it took up to 3 or 4 weeks to dye a piece of fabric. Now, to do it synthetically made that task much, much simpler. And this was the Industrial Revolution, when things were growing at an absolutely enormous rate and enormous speed, and the dyeing industry needed a technique that could actually dye things much quicker than in the past.
After borrowing money from his family, William Perkin set up a small factory just outside London and started producing large quantities of dye for the growing textile industries of England's north.
Well, this discovery led on to lots of other things. Later in his life, Perkin produced the first synthetic perfume, and other people then began to use the technology for producing other things. And today, most of the modern pharmaceuticals are produced by the same industry, all cosmetics, etc. Perfumes, of course, fertilizers, plastics, lots and lots of things, including car tires, for instance, and the oil that goes in your car, are all produced these days by the petrochemical industry, which is really the same industry as the original coal tar industry.
The Industrial Revolution was really a very clear driver of this emergence of a new colour technology. People were experimenting with chemistry as never before. They were trying to find new ways of combining elements into useful substances. So as a result of this, important innovations in colour came about as an offshoot.
A new and very vivid palette emerged, and among the beneficiaries were the French Impressionist painters.
The Impressionists pretty much cleared their palettes of any of the dull ochres that had been used before, and they insisted that they would use just these bright new colours, and they painted in a very bright sort of prismatic style, too bright in fact for contemporary tastes.
Painters like Van Gogh used the new palette to depict the towns and cities transformed by the industrial landscape. The new colours did shock. They revolutionized colour perception and turned art on its head. Painters moved away from realism to abstraction. The subject of a painting was no longer the important thing. In a sense, colour itself became the subject.
Eventually, the object, if you like, in painting disappeared altogether, and what you were left with was pure colour. Because the colour itself was so rich and vibrant, they felt that that was all they needed, that was all they wanted to say.
The 20th century was the age of the consumer, and colour was used to persuade people to buy. Everything from fashion to automobiles. As the decades passed, we saw the emergence of new colours and styles that led to the democratization of colour. Colour for the masses. The industries and practitioners who work with colour have tried to define and quantify it. Today, there are 8 major colour systems in existence. Some systems are better for architecture, others are better for printing. The system you choose depends on the need. One of the most successful companies to codify colour is Pantone in New York. If colour is a language, they've written a dictionary.
Well, I've been called the colour utility by some and the colour mafia by others.
Lawrence Herbert joined Pantone as a printer in 1956. In 1962, he bought the company, an opportunity made possible by a very smart idea.
As I was doing this printing work, I realized how confusing it was. When somebody wanted a specific color, we'd have to match it, and if we didn't know the exact pigments that the printing manufacturer had used, you couldn't match it properly. It would change under various lighting conditions. Pantone created the international language of color. It's used all over the world. Whether you're in China, India, New York, or someplace in Africa, that if you need a color, you just don't say red, blue, green, something like that, because you need a complete identification for that color. And so I created this numbering system which if we say, I want Pantone 485, the entire world knows what you're talking about.
Pantone has exactly defined a vast palette of colors through the use of spectrophotometers. Every color's hue and chroma is measured and then given a name and number. By quoting the Pantone code in an advertising company in New York, a client in Hong Kong can be certain they're talking about exactly the same color.
As it went forward, people were using it to identify everything, showing that there was a definite need for a definitive language of color. People use it to specify the color of goldfish. People use it to specify the color of plums, walnuts, things like that.
Coca-Cola Red is a Pantone color. So is Barbie Pink.
You can't own a color. Tiffany doesn't own that blue. They use it on their box. They make it very popular. They can stop any other jeweler from using that particular color because it's associated with Tiffany. Just as Kodak said, if you put film in a yellow and black box, you're copywriting out, you're infringing on our business.
In the electronic age, we are producing more colors than our eyes can discriminate, and they are brighter than ever. Phosphors and pixels give us the means to manipulate the color of our world in ways barely dreamed of. Japanese teenagers draw on diverse media to add color to their world. The clothes and costumes they wear are inspired by movies, manga magazines, and even reach back to kabuki traditions.
X-Japan のヒデさんのファンなんですけど、時代がちょっと違うんですけど、そっちが早くて、こっちがもうちょっと後の。はい。お母さんは認めてくれてます。そうですね。なんかちょっと呆れてますけど、うちの場合は呆れてるけど、まあやりたいんだったらいいんじゃないのみたいな。
Their world is inundated with imagery and colors and exciting new ways to use them.
Now I'm making fashion clothes made with fab cell. Fab cell is a changing color textile.
Fab cell is woven from strands of hemp impregnated with ink, the same ink used in LCD screens. The ink will change color when heat is applied. The heat could come from electricity sent through strands of wire woven into the fabric. Or alternatively, it could be body heat.
Imagine you are wearing clothing, it can change color depending on the temperature. By hugging somebody, your silhouette will be affected to the clothing, and gradually the color will be lost as your love between your boyfriend or girlfriend.
Midori and Akira have significant interest from Japanese industry, but they still have some hurdles to cross before they can go into production.
And the first problem is washability. And we cannot wash the fab cell. And the second problem is battery. Yeah. Midori, how much battery does it?
Now 45 voltage, so high voltage.
It's very dangerous for a human body.
The search for new color continues. New ways of using colors that have the potential to completely transform the way we live. Colors that are glimpsed in the flutter of a butterfly's wing. Some of these butterflies were collected over 200 years ago. The colors are as vibrant today as ever. The iridescent blue survives because it's not a pigment, but a result of light reflected off the structures in the wing. structures that do something very special to light.
Most colour is due to the presence of materials that absorb a particular wavelength of light. And so dyes and pigments all absorb a particular wavelength of colour. In structural colour, you can actually produce colour from materials that are actually transparent. And the way that you do that is by using optical effects like diffraction and interference.
As part of her work developing advanced fibre optic technology, Marianne Large is exploring just what the structural colour in a butterfly's wing does to light. By directing a laser onto the sliver of wing and adjusting the angle of reflection, Marianne is able to record levels of colour intensity.
Sometimes the colour response of those butterflies is very interesting because when you look at them you think that there's nothing special about them, but if you get them at the right angle they'll have this intense flash of colour. That is the signature of structural colour.
By exploring the microscopic structures, Marianne is hoping to find new ways to harness the power of colour and light.
All of the structures that we find in butterfly scales are the product of millions of years of evolution. If we could identify designs that achieved something similar in a more processable material, like a polymer, for example, then there'd be a big payoff for that.
Optical fibres are made from polymers. They use light to carry data. Everything from international communications to television.
The most interesting and profound of those implications is to be able to use light in a similar way, for example, that we use electrons now.
When it enters our house, light from current fibre optics laden with data is limited by our computer's modem. So the speed of light is reduced to the speed of electronics. By applying the physics of structural colour to fibre optics and its switches, electronic modems will be a thing of the past. A revolution will take place. Data will travel unencumbered at the speed of light.
The way that we manage to encode a lot of information into those optical fibres is to, if you like, associate a particular colour or a particular wavelength with each signal.
Each wavelength, each colour will carry distinct and separate volumes of data, nanoparticles apart. Information will be instantaneous. Business, media, universities and research will be transformed. Superficially, the house of the future may look familiar, but with the touch of a button, our lives will be incredibly connected to the world outside.
It will be a house of the world as much as a house that exists in a neighbourhood. We're a very information-hungry species. We're a very curious species, and I think that it will make knowledge much more available. It will reduce barriers between people. It will reduce barriers between countries, between cities. It will be possible to have really good video links to anywhere in the world at the press of a button.
Now we are using PC. Everybody can change the wallpaper of the PC desktop. But please imagine that you can change the wallpaper of your own room. We can download any image from the internet to the room. And if the wallpaper is made of Fabcell, we can apply that image to our own room.
Colour and technology continue to be intimately linked. From the structure of a butterfly's wing to holographic reality. Soon, movie entertainment will be convincingly three-dimensional. Colour, a vital but elusive force, will continue to astonish us and fuel our dreams. From our very first sunrise, colour has reflected our identity and our place in the world. It communicates a host of meanings, everything from warning us of danger to declaring our spiritual beliefs. But one of the biggest mysteries remains. Just how do colours affect us physically and mentally? Does red excite and blue calm? The answers are not straightforward. The power of colour is the subject of our next episode.